Water is so normal that we almost never think about it. But what if I told you that a tiny spider can walk on water? Trees can pull water upward over 100 meters, and all of this happens because of invisible molecular attractions. Today, we're not just talking about water, we're talking about why water makes life on Earth possible. Water doesn't behave like most liquids. It sticks to itself. It resists breaking apart, and its molecules are constantly forming and breaking bonds, millions of times per second. All these extraordinary properties come from something very simple: the structure of a single water molecule. At first glance, a water molecule looks almost boring. One oxygen atoms, two hydrogen atoms, arranged in white V shape. But here's a twist. Oxygen is more electronegative than hydrogen. That means it pulls shared electrons closer to itself. So instead of electrons being shared equally, they spend more time near oxygen. This creates polar covalent bonds. Oxygen becomes slightly negative. Hydrogens become slightly positive. And suddenly, water isn't neutral anymore. It's polar. Now imagine millions of water molecules packed together. The slightly positive hydrogen of one molecule is attracted to the slightly negative oxygen of another. This attraction forms a hydrogen bond. Hydrogen bonds are weak, about 1/20th as strong as covalent bonds. But here is what makes them powerful. They form, they break, and they reform. Each bond lasts only a few trillionths of a second. Yet at any moment, most water molecules are hydrogen bonded to their neighbors. Water becomes a constantly shifting molecular network, and from this network, new properties emerge. From hydrogen bonding arise four major properties that make Earth suitable for life. Today we'll focus on one of them: cohesive behavior. Because of hydrogen bonds, water molecules stick together. This is called cohesion. Most liquids flow freely and separate easily, but water doesn't. At any moment, many water molecules are linked by multiple hydrogen bonds, making water more structured than most liquids. Collectively, these bonds hold water together like a flexible net, and this leads to one of water's most famous features. At the surface of water, something special happens. Water molecules at the top are bonded to the water below them, but not to the air above them. This creates an ordered surface layer, and the result is high surface tension. Water behaves as if it's coated in an invisible film. That's how some insects and spiders can walk on water without breaking the surface. That's hydrogen bonding at work. Now let's scale up from insects to trees. Water travels from the roots of a plant all the way to the leaves, sometimes over 100 meters upward. But how? First, cohesion keeps water molecules linked together in a continuous column. When water evaporates from the leaves, it pulls on the molecule below it, which pulls on the next, and the pull is transmitted all the way down to the roots. Second, adhesion helps. Water also sticks to the walls of plant cells through hydrogen bonding. This adhesion helps resist gravity pulling the water downward. Together, cohesion and adhesion allow plants to transport water to heights that seem impossible. And we're just getting started. In the next video, we'll see how water controls Earth's temperature and becomes the ultimate solvent of life's chemistry. Because water isn't just where life exists. Water is why life exists.